Welcome to the deep dive. Ever wonder how complex software systems manage to, have different parts cooperate without stepping on each other's toes?
Yeah, it's a big challenge.
Well, that's essentially loose coupling, and today we're digging into a specific technique for achieving it. We've got these sources you sent over from O9 Design Patterns command.pdf.
Right, they focus on the command design pattern.
Exactly. A pattern designed precisely for this kind of flexibility. So our mission today is to unpack what this command thing is, how it helps, and why it's, well, such a useful tool.
Absolutely. Think of it maybe like setting a task request via an internal memo. The person sending the memo, the requester, doesn't necessarily need to know exactly who will handle it or all the little steps they'll take.
Okay, I like that. So it's about separating the request for something
From the object that actually does the work. That's the core idea.
Got it. So let's look at a scenario from the source material to make this more concrete. Imagine a travel agency application. The manager wants an operator character, maybe a class called operator, to handle various actions, making reservations, processing sales for accommodation, transport packages, that kind of thing.
We're at a common setup.
Yeah.
But you can see the problem brewing, can't you? If that single operator class directly knows how to book a hotel and reserve a flight and process a sale.
It gets complicated fast.
Exactly. It becomes this, well, sort of monster class. Really hard to change one thing without potentially breaking another. It's all tangled up.
So the command pattern offers a cleaner way.
Precisely. The source breaks it down nicely. First, you have the command itself. Think of this as just an interface, like a standard form that says there's an action to be performed. It's abstract.
Okay, like a template for an action. Then you have what the source calls commandavanzar or commandareserver.
Yeah, those are the concrete commands.
Yeah.
So translating roughly like a sale command or a reservation command, these fill in the details on that template.
Ah, so these are the specific instructions for, say, how to actually make that sale or book that room.
Exactly. They implement that abstract command interface. They know what needs doing for that specific task.
And who? Who actually does the work? The booking or the selling?
That's the receiver. The source mentions patch-heuristic tourist packages, basically. Like patch Gazar, an accommodation package, or patch a transport or a transport package.
So the receiver is the thing that knows how to, interact with the hotel system or the airline system?
Precisely. It's the object that ultimately performs the action requested by the concrete command. And you can have a whole family of these receivers.
Okay, command, concrete command, receiver. What was the last piece? The operator.
Right, the invoker. In this scenario, that's our operator class. But now, its job changes dramatically.
Oh, so...
Instead of containing all the logic for every action, the invoker just holds onto a command object and tells it to execute. It might not even know which specific concrete command it's holding or which receiver will ultimately do the work.
Oh, I see. So the operator just says, do this command, and the command object takes care of figuring out the rest.
Basically, yes. It decouples the operator from the details of the action. Now, the source mentions two ways this can work.
Okay.
One is simple. The invoker just triggers the command, run it, done.
Straightforward enough.
But the second way is really powerful. The invoker can keep a history of the commands it has executed. It saves them in a list, perhaps.
Wait, so like a log? Why would it do that? For undo.
You got it. That's the magic the source highlights. If the invoker stores the commands, and if each concrete command also knows how to reverse its own action and undo method, then you can easily step backwards.
That's brilliant. So you can just tell the last command, undo yourself. Huge flexibility.
It really is. And the source connects this to real-world uses.
Yeah.
Think about macro-URL macros in software.
Yeah, like recording a sequence of actions.
Each step in that sequence is essentially a command. Or just working with files hitting Ctrl plus Z or CMD plus Z, that's undo. It's very often implemented using something like the command pattern.
Any situation where you might want to revert something.
Or replay something, or queue things up. It's incredibly versatile.
The source also mentions connections to other patterns, like memento and adapter. Briefly, how do they fit in?
Well, memento is often used with command for that undo capability. Memento is about capturing an object's internal state so you can restore it later. Perfect for saving the state before a command executes, so undo can put it back.
Makes sense. And adapter.
Adapter helps you make existing classes work with your command structure, maybe as receivers, even if they weren't originally designed for it. It helps integrate things.
Okay, so wrapping this up, the big win with the command pattern is flexibility. Less tangled code.
Definitely. You get a system that's much easier to extend and maintain, because the component asking for an action, invoker, isn't tightly bound to the component performing it,
Yeah.
receiver. You separate the what from the how.
Great explanation. It really clarifies how you can manage complexity. So here's a final thought for our listeners. We've talked about the power of undo in software thanks to this pattern. Stepping back from code, where in your own work, or maybe even just life, could the ability to easily reverse actions or decisions be really valuable? Something to think about, perhaps this concept of reversible steps.